to session of wireless communication networks. Myself, Karthik, Assistant Professor, Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, mainly we discuss about the wireless local area networks topologies. Okay, in the previous session, we discussed the what are the wireless standards, what are the advantages of the wireless communication, what are the disadvantages of wireless communication, what are the improvements in the wireless communication we discussed in the previous classes. Okay, now we discuss about the wireless local area network topologies. Okay, coming to here, the students will learn from this topic. Here, the main thing, the types of wireless local area networks and their standards. Okay, with the help of these wireless local area networks and also the networking, it is a go with the implementing and the networking of the computing device. Okay, with the help of wireless local area network. Okay, the student will learn this knowledge from this topic. Okay, coming to here, in the mainly what are the advantages or disadvantages we discussed. Okay, coming to wireless communication, we have many advantages and disadvantages. Okay, some of the advantages we can go with this wireless local area network topologies. Coming to here, what is a topology? Here, the topology means configuration of which mobile terminal communicates with another. Okay, the network. The network is a configuration. Okay, they're having the two types of topologies. One is a P2P topology and also second one is a infrastructure topology. Okay, coming to here, we're having the two types of topologies. One is a P2P topology and second is a infrastructure topology. P2P means a one-to-one. P2 means one-to-one topology. It is also called hoc topology. Coming to infrastructure topology. Okay, what is the difference between these two topologies? What is the difference? Okay, coming to P2P topology, there is no need of any infrastructure. Okay, for example, here this is a one device, this is another device. Okay, we can connect it. Okay, we can connect it. This is there is no infrastructure. Coming to infrastructure topologies, we need an access point, nothing but a router. Nothing but a router. From that, we can connect the one device, two device, three, and also four devices. Okay, it needs infrastructure. It needs infrastructure. Okay, but here no need of any infrastructure. Okay, this is the main difference between the P2P topology and also infrastructure topology. Coming to wireless local area network topology, having the two types. One is a P2P and second one is a infrastructure topology. Okay, coming to first one, P2P hoc topology. Just now we discussed here there is no need of any infrastructure. Coming to in this topology, it applies to reconfigure the networks that can operate without need for a fixed infrastructure. And also this is the easiest wireless local area network mode to configure the at least hardware devices. Okay, here mainly no need of any fixed infrastructure. It also work without infrastructure also it can operate. Okay, this is a very easiest wireless local area network mode. Okay, this topology very easiest mode to configure the requirement of the particular hardware. Okay, this is a one type of topology. Coming to another one. Okay, you can see here this is a topology network in the P2P topology. Coming to here, we can connect the one device to one device. Okay, here desktop to laptop or desktop to tablet or laptop to tablet. Okay, only one connection is possible. Okay, nothing but a one-to-one connection. Also, we can call the P2P topology. Okay, this is some networking for the P2P topology. Okay, and also we can see the multi-hop hoc network topology. Okay, previous one that is a P2P single hop. This one is a single hop network topology. Coming to here, multi-hop. Multi-hop means in some hoc networking application where users may be distributed over a wide area, and also terminals may be able to reach only portion of the other users in a network due to transmitter signal power limitations. Okay, here we can share the distribution of the wide area network. Okay, that is nothing but a multi-hop hoc network. Okay, here we can say we can reach the other users also from this network. Okay, that is a multi-hop hoc networks. Okay, coming to here we can see what are the situations comes under the multi-hop network. Okay, in these terminals we can have to cooperate in carrying messages across the network between the widely separated stations, and also it is a function of the this function whatever having the design, the function is called multi-hop ad hoc networks. Okay, in this one each terminal should be aware of the neighboring terminals in its coverage range. Okay, and the access point. Okay, from this access point, okay, from this access point we can connect the many devices, but it should be the neighboring device should be terminal should be in the coverage range only it can access. Okay, whatever having the devices we can cover with the net coverage range that we can connect the neighboring terminals. This is a comes under the multi-hop network topology. Coming to in this one infrastructure network topology. Okay, it is a network. It is designed for large coverage area and also multiple base station or access point operations. Mainly, it needs infrastructure. It needs infrastructure. This network, this topology needs infrastructure topologies. Coming to wireless local area networks, we are having the two types of topologies. One is a P2P topology and second one is a infrastructure network topology. Okay, first one, no need of any infrastructure. Without infrastructure also we can operate in the network. Okay, coming to in this network topology, we need the infrastructure. Okay, in this wireless local area network mode, the hardware or software access point is configured as a part of the wireless local area network design. Okay, this access point can provide connectivity for all the systems on the wireless local area networks. Okay, coming to see here, this is the access point, nothing but a router. Okay, from this one we can connect the devices, this desktop and a laptop, tablet, mobile. Okay, these we can connect through the access point. Okay, the connectivity for all the systems on this wireless local area network. Okay, in that this is a infrastructure. Okay, this is a infrastructure. In the previous one there is no access point, that's why without infrastructure also we can operate that particular network. But coming to here, infrastructure network topology, it needs any access point operations or also otherwise multiple base station also it needs the infrastructure network topology. Okay, whatever having that configured with the software or hardware also it can configured as a part of the wireless local area networks. Okay, coming to the wireless network card, and each computer is configured to the specific access point to the specific wireless local area network, and all traffic to the other computers on the wireless local area network is directly through the access point. We can observe here from the access point only we can maintain the all the traffic of the other devices. Okay, for example, if you go with the any broadband, okay, from that they give the 50 Mbps speed or 100 Mbps speed. Okay, based on the requirement we can go with the access point. Okay, they through the some network configuration they give the our requirement speed. Okay, all the traffic should be carried by the these networks. Okay, this is access point. Coming to here you can see infrastructure network topology. Okay, this is one access point. Here we can connect with the LAN. Here we can connect with the LAN. Okay, here we can connect with the wireless. Okay, the infrastructure network topology, access point, server, printer, and desktop. Okay, here we can connect with the desktop, laptop, and tablet. The wireless here wired. That means LAN only we can connect it. Okay, this is a infrastructure network topology. Next one is a comparison of DAC and infrastructure network topologies. Okay, here we have in the different comparisons. One is flexibility, controllability, routing complexity, and reliability. Okay, these are the main parameters for the comparison of the ADAC and infrastructure network topology. Okay, first one is flexibility. The flexibility is the in the what are having the P2P topology and also infrastructure network topology. The operation of infrastructure networks requires deployment of a network infrastructure, which is very often too consuming and expensive. Okay, first one, flexibility means we're having the two topologies. One is a P2P and second is the infrastructure. Okay, coming to infrastructure means we need one base station, we need some access point. Okay, it is a compared to P2P, it is expensive. Okay, coming to other networks are inherently flexible and can be set up instantly. Okay, because here there is no base station, there is no access point. Then it is flexible to the all the connection. Okay, but it needs time consuming for the installation and also it having the expensive. Okay, coming to next one, ad networks are always used for temporary applications where flexibility is of prime importance. Okay, if you need the connection, we can connect the one-to-one connection. Okay, direct instantly we can connect with the another person. Okay, this is the flexibility. But coming to here, another comparison, controllability. Okay, to coordinate a proper operation of a radio network, one need to centrally control certain features such as time synchronization, transmitted power of the mobile stations, it operating certain area, and so on. Okay, coming to infrastructure network, all these features are naturally implemented in the base station or access point. First of all, you can see the main comparison of the controllability of the particular operations. Okay, if it is a go with that, coordinate the operation of the radio network, one need to centrally certain features at the time synchronization. We need these features: synchronization, transmitter power. Then it can operate it by in certain area. Okay, the power of the mobile station we need for these parameters for the controllability. Okay, coming to infrastructure network, and all the features are naturally implemented by the base station. What are the features? We having that synchronization, transmitter power of the mobile, and also station operating in a particular area. These are totally controlled by the in this infrastructure topology base station or otherwise access point. Coming to inner network, in an ad network, implementation of these features requires more complicated structure, demanding challenges in all terminals. Okay, here with because we have no need of any infrastructure, no need not there is infrastructure. That's why we are unable to go with all the features. Because if you go with the broadband connection, we can take in all the features, whatever having that synchronization, transmitted power, whatever having that operating in the certain area, those we can take in the infrastructure naturally implemented by the base station. But in this, not possible. And coming to next one is routing complexity. In a multi-hop P2P networks, each terminal should be able to route a message to other terminals. Okay, this compatibility requires each terminal to monitor the extents of the other terminal should be able to connect those available immediate neighborhood. Okay, this is one thing you can see. In the coming to single hop and multi-hop P2P networks, each terminal should be able to route a message to other terminals. This one is a requirement of the connecting the routing for the these network, the P2P network. And also whatever having this P2P network, it is a compatibility requires each terminal to show the monitor to the extension of the other terminals. Okay, we can see the whatever having the terminals connected to the particular network, we can also monitor the all the extension of the terminal also. It able to connect those available immediate neighborhood. Okay, whatever having that, we can neighborhood terminals also we can monitor by the this particular routing complexity. Coming to for this routing algorithm that directs information the next appropriate terminal. Implementation of these next appropriate terminal, implementation of these features, it adds to the complexity of these features of the particular terminal of the network. Coming to infrastructure and P2P, the single hop, this problem does not exist. Only this problem for only multi-hop P2P network, multi-hop P2P network. For the coming to another one, single hop and also infrastructure network, this does not exist for this particular problem. Okay, this is another advantage. Coming to another comparison, the reliability. Okay, infrastructure networks are a single failure point. Networks, if the base station or access point fails, the entire communication network is destroyed. Okay, coming to infrastructure networks. Coming to infrastructure network, any single failure in this point, the entire communication will be destroyed. This problem does not exist for the ADAC P2P configuration because if it is a access point, okay, it is an access point, then we can connect the all device. If the any failure in this point, any failure in this point, the entire device is also destroyed from this communication network. Okay, this is for only infrastructure network. Coming to peer to peer, there is no infrastructure. It is a one-to-one connection. Okay, one terminal to another terminal connection. There is no need of any. There is no any failure of this particular network. This is a reliability. Mainly in this ADAC and infrastructure topologies, we are having that four comparison parameters. One is flexibility, and second is controllability. Next, routing complexity, and also the next one is reliability. These are the four comparison for the ADAC and also infrastructure network topology. Coming to next one, introduction to wireless local area network standard to the IEEE 802.11. Okay, it is a international standard. Whatever having the IEEE 802.11 is the standard, international standard. Okay, this standard describes the wireless local area network Cat6. Okay, this IEEE 802.11 is a international standard. It describes the wireless local area network characteristics. Okay, this Wi-Fi corresponds certification name issued by the Wi-Fi Alliance Group. Whatever having the right now different IEEE standards, those are certification by the Wi-Fi Alliance Group. Okay, here this standard, whatever having the 802.11 standard, it ensures the compatibility between the hardware device. Okay, then that is certified by the Wi-Fi Alliance Group. Okay, the initial stage we are having the IEEE 802.11. Okay, coming to what we know, it generally in every home we have the Wi-Fi connection. With the Wi-Fi, what we have to do? Okay, how it is works. That is we know everyone. Okay, coming to Wi-Fi provides high-speed connection to laptops, desktops, and also any other personal digital assistants. Okay, if it is location in the indoor, we can go with the 20 to 50 meters. If it is outdoor communication, we are having the 100 meter. Okay, the based on that network also we can assume the what is the indoor connection radius and outdoor radius. Okay, that Wi-Fi provides started providing the internet access point to public locations such as railway stations, airports, hotels, and matter having that wireless networks. Okay, nowadays you are observing, if you go with the railway station, the free Wi-Fi of the Wi-Fi connection is there. Coming to hotels, any restaurant, airports. Okay, they provide the some Wi-Fi hotspots. Those are called Wi-Fi hotspots. So whatever having the internet, the Wi-Fi providers providing internet to the public locations, that is referred as a Wi-Fi hotspots. Okay, that is a Wi-Fi hotspots. For example, if you go with the any railway station, it is first of all they are asking the authentication. Okay, if you give your mobile number and also then you can enter the OTP, then the automatically internet will connected to your mobile devices. Okay, like that they are connecting the Wi-Fi hotspots to the public locations. Okay, this is a Wi-Fi whatever having that radius in the indoor communication and also outdoor communication applications. The first one here we can see the first one. 802.11 is a specific standard. The first standard is the IEEE 802.11. Okay, this standards defines the MAC and also physical layers of a wireless local area network. Okay, this is the first standard. The based on that MAC layer, medium access control, and also physical layers of wireless local area network. Okay, actually we are having the total 7 layers. Okay, we know it. What is a physical layer? What is a data link layer? Network layer, transport layer, session layer, application layer. Okay, we are having the total 7 layers. In that form, in the bottom we are having the one is a physical layer, one is a data link layer. These two layers only communicating in the wireless local area networks. Okay, here in the data link layer also we are having the sub layers, that is the LLC and also MAC layer, that is defines the specific standards of the 802.11 standard. Okay, the first one is a 802.11 standard is a MAC standard. It is a low data rate. It supports only 192 Mbps data rates. Okay, that is a MAC standard. The coming to first version of standard operates at the 2.4 GHz ISM band. What is ISM means? Industrial, scientific, and medical. It band allows the some modulation techniques. That is a direct sequence spread spectrum technique, and second is a frequency hopping spread spectrum implementations. Okay, here This is a first standard. It supports only 1 and 2 Mbps data rate, and also that operate frequencies are 2.4 gigahertz, and also what is the ISM band, industrial, scientific, and medical band. Okay, the modulation techniques are the direct sequence spread spectrum technique, and also second one is the frequency hopping spread spectrum implementation. This is a first standard. Next we can go with the another standard. Okay, the first is a version standard. That is next two all are coming from the 802.11 extensions only. Okay, the initial stage only we having the 802.11 only. After that we can go with the 802.11b. This is a same physical extension of the version standard only, but it is the same operating frequency is 2.4 gigahertz, and it allows high data rates 5.5 to 11 Mbps. Okay, the technique used here, complementary code keying. Here the technique used in the complementary coding keying. Okay, this is a extension of the version standard only. Okay, the previous one we're having the 802.11. It data rates at up to 192 Mbps. The operating frequency is 2.4 gigahertz. The modulation techniques are the direct sequence spread spectrum and also frequency hopping spread spectrum. Coming to here, it operates same frequency compared to version standard, and also but high data rates compared to the previous one. Okay, here high data rates means 5.5 to 11 Mbps. Okay, it is techniques used here. The previous one we are used the direct sequence spread spectrum and also frequency hopping spread spectrum. But coming to here, we can use the modulation technique is a complementary code key. Okay, this is another one. Okay, next one is another standard of the same version standard, the extension of the 802.11 standard. This is the 802.11a. Okay, but it operates 5 gigahertz unlicensed band. Okay, coming to previous two extensions, that are having the previous two extensions. One is 802.11 and also B. Those are operating at 2.4 gigahertz, but this one operating in the 5 gigahertz. Okay, but allows data rates are the 6 to 54 Mbps. Okay, the using techniques are the orthogonal frequency division multiplexing, that is a OFDM. Here we can use it. Okay, this is another extension of the same version standard. That is a 5 gigahertz operating frequency, that is an unlicensed band. Coming to data rates compared to the previous one, those are the high data rates. Okay, here we are using the technique is a orthogonal frequency division multiplexing. Coming to another extension of the 802.1, this is the next extension of the 802.11 standard. This is a 802.11g. Okay, it operates 2.4 gigahertz ISM band. Okay, it is ranging from 1 to 54 Mbps. The same thing here, having that this is a hybrid model, like that we are having the hybrid model. If it is a 192 Mbps, same thing we can go with the direct sequence spread spectrum mode. Okay, if it is a 5.5 and also 11 Mbps operating the CCCK mode, and also the next high data rates. Okay, that is you can operate in the OFDM mode. Okay, this is a extension of the 802.11 G extension of the 802.11 standard. Okay, mainly here we having the total 4 standards. The first one is a version standard is 802.11. It is a operating frequency 2.4 gigahertz, and also we are using that particular modulation technique is the using two modulation techniques. One is a direct sequence spread spectrum and second is a frequency hopping spread spectrum. Those are the two techniques for that particular version standard. Okay, but it supports only 192 Mbps. Same operating frequencies are 2.4 gigahertz. Coming to another extension, 802.11b, it is operating frequencies same as the previous one, same thing, that is a 2.4 gigahertz. It operated in the 5 to 11 Mbps. Okay, the compared to previous one, we are having the high data rate. The operating frequency is the same thing, but here we change the 802.11a is the 5 gigahertz unlicensed band. Okay, ISM band. That is ISM band means they can view of the industries, industrial, scientific, and medical. Then only they give the some particular operating frequency. The next one is there we are using operating modulation techniques is OFDM, that is orthogonal frequency multiple division multiplexing. Next, here this is a hybrid model of the remaining 3 models. So here we are having the same thing. Operating frequency is 2.4 GHz ISM band, and the ranging from 1 to 54 Mbps, and also we can use the 192 Mbps operated in the D++ mode, that is a direct sequence spread spectrum mode, and also whereas you can use the 5.5 and to 11 Mbps operates in the CCK mode. The remaining high data rates are operating in the OFDM mode. Okay, these are the wireless local area network standards of the IEEE 802.11. Okay, here you can see if it is a 802.11g standard, the OFDM technique data from the first one 802.11a, but operating in this 2.4 GHz. Actually, the original version of extension of the 802.11a, it is having the 5 GHz unlicensed. Okay, but coming to 802.11g, here some high data rates, you can go with the OFDM, orthogonal frequency division multiplexing here, but changing the 2.4 GHz, but taken technique borrow from the 802.11a. Okay, if it is a therefore operating frequency high data rates will be backward compatible with the 802.11b. Okay, these are the IEEE standards. The next one, up to now mainly we discussed the IEEE standards. Okay, their operating frequencies, their modulation techniques, their data rates. But coming to here, 802.11 architecture. Okay, this architecture comprises the station service, station, access point, wireless medium, basic service set, distribution system, and also extended service set. Okay, mainly here this architecture includes the station services and also distribution service. Okay, but these we are having that compression of the all the mixing of that particular architecture. Okay, there we having the different stations, access point, wireless mediums, and a basic service set, distribution service set, extended service set. Okay, then we can go with the IEEE 802.11 architecture. Mainly this architecture includes station services and also distribution service. Coming to station services, we are having the 4 station services, 5 distribution services. Mainly we are having the 4 station services, 5 distribution services. Okay, what are comes under the station services? What are the services comes under distribution service? We will see. Okay, here you can see the basic service set is a set of all stations that can communicate with each other. Okay, you can observe what is the basic service set. Okay, it is a set of all stations. It's a set of all stations. Then it can communicate with each other. Mainly we having the 3 types of basic service sets. We having the 3 types of basic service set. Okay, all are comes under the architecture. Okay, all these service these are comes under the service sets. But here you can see independent basic service set, and second one is a infrastructure basic service set, and next one is a extended service set. Okay, mainly we are having the 3 types of basic services. One is a independent basic service set, and second one is the infrastructure basic service set, and next one is a extended basic service set. You can observe here independent basic service set means here there is no infrastructure in between all the network connections. There is no infrastructure. This is an independent basic service set. Coming to here, we need the infrastructure for this basic service set. That is a infrastructure basic service set. It need one router, that is an access point. Okay, and the next one is an infrastructure mode basic service set. Here, whatever having the information, we can distribute it to the 2 access point. This is a distribution system. From that, we can go with the 1 access point, and one more access point. There we can connect all the networks. Okay, this is a infrastructure mode basic service set. Okay, this is a extended service set. Same thing coming to previous one, but here the services will be extended to the distribution system of the wireless communication. This is another basic service set. The mainly we having here 4 station service and 5 distribution service means here what are the station service we'll see. One is authentication. Second one is a de-authentication. Privacy. and data delivery. Okay, mainly we're having these four station services. Okay, one is authentication, de-authentication, privacy, and data delivery. With the help of these four station services, we can move on to the this particular architecture that we will see in the next session. What are having the four station services? Next, coming to distribution service, also we're having that one is association, de-association, re-association, and integration with the wireless local area network. That we'll see in the next session also. What are the four station services and what are the five station services? Mainly here you can see the what are the basic service set and also what are the wireless local area network standards you will see in this session. We observed what are the comparison also. First of all, we can see okay, mainly the wireless local area network topologies. We are having the two types of topologies. One is a P2P ADAC topology, and also it is also called ADAC topology, and second is infrastructure topology. Okay, mainly here no need of any fixed infrastructure. Then only we can move on to the peer-to-peer communication. This is a multi-hop ADAC network topology. You can observe coming to infrastructure ADAC network topology, we need the access point or otherwise any base station for the connecting to the other device and neighboring devices. Here you can see infrastructure node topology means here we need the one connection. From that only we can connect the other device to the wireless local area network and also Wi-Fi. It's need one infrastructure node. Okay, and we can have the comparison of the all the two topologies. One is the ADAC topology and also infrastructure network topology. When we need one flexible, we have the parameters of flexibility, routing controllability, flexibility, controllability, routing complexity, and reliability. These are the four comparison parameters for the ADAC and infrastructure network topology. The first one is the flexibility. Which one is the flexibility base? We all are say about the ADAC networks, because here there is no infrastructure, there is no installation for the connecting the network. But coming to ADAC network infrastructure topology, it takes the infrastructure and also we need one base station. Then it takes the time consuming and also expensive compared to the another network topology. Okay, coming to controllability, also we have the different features. Okay, that is a synchronization, transmitted power. Okay, those are comes under the mobile station operating features. Okay, that is all are mainly these naturally implemented in the base station, but there is no possibility in the peer-to-peer network. Okay, next one is a routing complexity. Here, routing complexity means here we need a connection of the multi terminals. Okay, that is only some problem for this routing complexity, but compared to single hop, there is no problem for that infrastructure also. Next, reliability means if it is any failure point in the access point, the entire communication will destroy. But coming to ADAC network, there is no problem for this reliability. The next one is the four standards for the IEEE standards 802.11. It mainly describes the wireless local area networks. Here mainly we are having the 802.11 and B, A, and G. These are the main four standards for this wireless local area network standards. And also we are having some improvement of this particular enhancement of the particular wireless local area network standards also will be there. That will also we can see in the next session. Mainly in this session we discussed what is the original standard 802.11, what are the data rates, what are the modulation techniques we discussed in this main session. This is a 802.11. Here we can use the MAC and also physical layer. It supports only 192 Mbps. It operating at the 2.4 GHz. The modulation techniques are the direct sequence wide spectrum and also frequency sweeping wide spectrum. And coming to here, 802.11b, this is the extension of the first one. Here operating frequency is 2.4 GHz. The high data rates 5.5 to 11 Mbps, and also this technique has a complementary code keying. The next extension is the 802.11a. Here we can use the orthogonal frequency division multiplexing. And the next one is a hybrid model. This is a 802.11g, combination of all the previous three standards. Here we can use the three different modulation techniques. One is a DT replace mode, and CCK mode, and third one is a WebDM mode. Okay, this is the wireless local area networks. In this next session, we can discuss the what are the 4 station services, what are the distribution services. We'll discuss in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.